Hello everyone. Today we're going to be talking about multi-threading and solving the producer and consumer problem using pthreads. The producer and consumer problem is a classic example of multi-process synchronization problem. The problem describes two processes, the producer and the consumer, who share a common fixed size buffer as temporary storage. The problem may seem theoretical, however, there's widely applicable real world scenarios with the producer and consumer. For example, print spooling, task scheduling, and many other. In our lab file, producer and consumer, the producer and consumer threads are created in the main function. They're bounded length FIFO queue to place and remove integers. The first problem that arises with the producer and consumer is busy waiting. And busy waiting is when a thread wastes CPU cycles checking one condition repeatedly. So, for example, if you reach a condition block, if else, and then the thread just keeps on wasting, going over the same condition over and over again to see if it's being fixed. However, the problem does not get fixed because it should be fixed by another process. However, because the thread is wasting CPU cycles, it's stuck in an infinite loop. That's the busy waiting problem. How we solve the busy waiting problem is by using semaphores. A semaphore is an unsigned integer that threads can increase or decrease atomically, avoiding the need for busy waiting. Another important concept that we've already talked about multiple times is mutual exclusion. Often implementing a mutex, this will ensure that only one thread can access the shared resource at one time. Once you've implemented these solutions, you can run various tests to verify that the semantics are as expected. This is crucial for understanding the problem of the program, which is producer and consumer. Use make tests to see what differences are there. Now I have a tiny piece of code that we can see how I fixed the naive problem of producers and consumers. So let's go ahead and look at this. I am not going to make this today since this doesn't really do anything. It's just a code to help you understand how this code works. So firstly, let's go ahead. We have three headers: pthread, semaphore. Pthread we've seen before because it's used for POSIX threads. Semaphore is a new header. This is included to access the semaphore functions in C, and then we have the standard input output. Then we over here in the first two, the two global variables are sem. This is our semaphore variable. And then we have pthread mutex t mutex. This is our mutex variable. Then we have a producer function. In the producer function, this simulates the producer's actions. Sem post ampersand sem is a signal to an item that has been produced and unlocks the mutex. Pthread mutex unlock is the unlock function that allows the consumer to access the shared resource. And then we have a consumer function. In the consumer function, we have a sem wait, which until an item is produced, it locks the mutex, and then we have a lock to access the shared resource. And then inside the main function, we have two threads. We initialize our semaphore, we initialize our mutex, our mutually exclusive space. We create our threads. We have a join function to wait for threads, and then we destroy our semaphore and our mutex after we're done using them in our main function. And that's basically a naive solution of how you would solve this week's lab. Hopefully this was helpful, and have a nice day.